In the enlargements chapter, we looked at objects and their enlarged images, images which, were enlarged versions of the objects given a particular scale factor. So we'd have an object and would enlarge it to, say, a scale factor of 2. That would mean that every side of the object would be a multiple of 2 times the size of the object sides. Okay, so we can find the scale factor k using this important formula here. K is equal to the length of an image side divided by the corresponding length of an object side. Okay, we can find k in 2 ways. Sometimes you might be given an object like this, A, B, C, D, which fits a given grid exactly and perfectly. And we might have its enlarged image, A prime, B prime, C prime, D prime. And we can find, just by looking at the object and the image, we can see that the side C prime, D prime is 2 times that of the side CD. This is 4, this is 2, so K is equal to 2. Or we could actually use the formula. Okay, we could use the formula and say, okay, K is given by the length of an image side, say C prime, D prime, divided by the length of its corresponding object side, CD. So that would be 4 over 2, that's equal to 2. So, sometimes we have to use the formula because we could have a grid and, our image or object might not actually, points on the image might not actually hit the grid where we want them to, like this point here. So it's better to have the formula to fall back on. Another important formula which relates scale factor and to object stroke image areas. We can use this formula that the area of an image is equal to the scale factor squared, k squared, times the area of the original object. So for the above example that we just saw two minutes ago, we had a 2 by 2 and the scale factor was 2, and that gave us the 4 by 4. And the area of this is 4, and the area of this is 4 times 4 is 16. And we can check using our formula here. The area of the image, that's 16, is equal to the scale factor squared, 2 squared, times the area of the object, which is 2 by 2, and that's 4. So that gives us 4 by 4, that's 16, this is 16, so that proves that this formula holds true and that we can use it in future examples. So how do we draw enlargements? Remember, these are enlarged images. These are enlarged images of a given object. Okay, so we need 2 pieces of information to draw an enlarged image of a given object. We need the location of the center of enlargement, or we might start calling that COE in the future for short, and the scale factor K of the enlargement. Okay, so let's say we're asked to draw an enlargement of this square here, ABCD, with a scale factor of 3. Okay, so we simply draw ABCD, and we draw a centre of enlargement, and we call that O, point O, and we can put this point, this centre of enlargement, anywhere we like. We can put it here, there, we can put it anywhere, but we'll just choose to put it here to the left of the object. Okay, so the first thing is we place the centre of enlargement, or we might be given that in the problem anyway. So the next thing to do then is to draw these lines, or rays as we'd call them, these dotted lines, from O through A, point A, all the way through, and also from O through B and all the way through, and O through C and all the way through, and O through D and all the way through. Okay, that's the first thing you need to do, is draw lines from O through each point and onwards. Then if we go to enlarge the point A, or find the image of A, which would be A prime on the image of on the image that we're about to produce, then we need to measure the distance from O to A, measure that with your ruler, and then multiply that measurement by 3, because K is 3, and you mark the distance from O, that 3 times OA, whatever that is, you mark that distance here, okay, along your ray line from O through A and onwards. So in this example here, O to A is 17 mil, and 3 times 17 is 51 mil. So this measurement here, if this page was enlarged to its proper A4 size, would be, if that's 17, that's 51 mil. Okay, and we do the same for point B. We measure O to B, multiply by 3, mark that from O all the way out to B prime. O to C, multiply that by 3, and measure from here, from O out to C prime, and the same O to D and all the way out to D prime. And we can see from our formula, the original formula, that an image side O, or an image length OA, is 3 times K times OA. Oh, sorry, it's important to remember that the length from this centre of enlargement to the image point A prime will be 3 times the length from the centre of enlargement to the object point A. So just to remind ourselves, where else can the centre of enlargement be? Because in the other example we place the centre of enlargement to the left of the object. Well, the centre of enlargement can also be on the vertex of the object. So here it's at A on the object. The centre of enlargement can be inside this object's triangle ABC at this point X, and we can see that the image is outside of the object because we measured from here to here, and then we multiplied that by whatever the scale factor was to get the image A of A prime, and same for B, B prime, and C, C prime. And actually here you can see that when the centre of enlargement is on the object at that point A, then the point A is also A prime. So what if our scale factor is less than 1? Okay, well, if it's less than 1, our image will be reduced, and a reduced image is known as an inverse enlargement. So let's say K was equal to a half, then our image side would be equal to half the length of its corresponding object side. Okay, so let's say we have an object A, B, C, and a centre of enlargement here, and we're looking to find the inverse enlargement given that K is equal to a half. Well, what do? It's similar but kind of in reverse. We measure, well, the first thing is we draw our ray lines from O through to A, O through to B, and O through to C. And then we measure OA, we multiply that by a half, and we mark that distance there at A prime. We measure OB, multiply that by a half, and we mark the distance here at B prime. And we measure OC, and we multiply that by a half, and we mark that point at C prime. And this is the image A prime, B prime, C prime of the object A, B, C, where the scale factor is equal to a half. And just to also mention for inverse enlargements, if the image B is twice the size of the object A, then K must be equal to 2. And we can say B is 2 times or twice A. But we can also say the inverse of that is that A is half of B, or half times B. So the scale factor for an inverse enlargement is always 1 over K. So if you have an enlargement of K equals to 3, the inverse enlargement is equal to 1 over 3, the inverse enlargement scale factor is 1 over 3. Sorry, not not the inverse enlargement scale factor, but just the inverse enlargement would be 1 over 3. And then how to find the centre of enlargement given an object and its image. So we're given an image, we're given an object, and a centre, we're looking to find the centre of enlargement. So we can find the centre of enlargement by joining two sets of corresponding points, like this point, and continue in its line, and this point, and continue in its line, and where they intersect, that's the centre of enlargement at O. And a couple of typical examples of problems that you'd meet with from this chapter. So the first one, we have two triangles, the triangle ABC, and AB prime C prime. And AB prime C prime is an enlargement of ABC where A is the centre of enlargement. We're asked to find K. Well, how do we do that? Well, K is equal to the image side over its corresponding object side. So if we take A prime C prime, we can see that's 8 plus 12 is 20. And if we look at the side A prime C prime's corresponding object side, that's AC, because A prime C prime is an enlargement of AC. That's equal to 8. So K is equal to 2.5. The scale factor, this triangle and this triangle here, the scale factor between the two is 2.5. Then we're asked to find the length of BC. Okay, so that's corresponding side for BC is actually B prime C prime. Okay, and we can just use the same formula again. Scale factor, which we now know, is equal to the image side over the object side, which is what we're looking for. So we can say that the scale factor is equal to the length of B prime C prime, which we know, divided by the length of BC, which we're looking for. Okay, so if we work through this formula here, we'll see that the length of BC is equal to 10 units. Okay, then we're asked to find the ratio of the lengths of side AB to AB prime. Well, we know the scale factor of one triangle to another is 1 to 2.5. So we've multiplied both sides by 2 here. We'll get the ratio is 2 to 5. That's the ratio of the length of the sides between AB and AB prime. Finally, we're asked, or we're told, if the area of the triangle ABC is 16, find the area of the triangle A prime B prime. Okay, so the area of the image, that's what we're looking for, is equal to the scale factor, which is 2.5 squared, times the area of the object, which we're given as 16. So 2.5 squared times 16 gives us 100 square units, which is the area of the image. And another example, a paperback 3/5 reduced from its original hardback is to be produced, or 3/5 of the size of the original hardback is to be produced. If the hardback cover is 18, how high will the paperback cover be? Well, we've given the scale factor, that's 3/5, and we are looking for the image, which is going to be the paperback, a reduced image, and we're given the object size, which is 18. Okay, so given all of that, we would say 3 times 18 is what it is, and divide by 5 gives us an image size of 10.8. In other words, the hardback cover is 18, and the paperback cover it would be 10.8. And that's a reduced or an inverse enlargement of 3/5.